ENDER 3 Extruder Upgrade. This is part 2 of the Greg's Wade extruder build here on Fat Man Makes. Before we start, make sure you click subscribe and check the bell so you don't miss the next great project coming up. We're going to jump right into it.
Alright guys, this is it. I just got back from Lowe's. And here's my receipt. $7 with tax. That's what we spent. What did we buy? So we have two 8mm by 60 bolts. We have a bag of Nylock 8mm nuts, some 5/16 washers, some number 6 flat washers.
And these are the number 6 machine screws by 2-inch with nuts. So we can use the second 8mm bolt, or we can use a piece of 5/16 threaded rod. Either way, I have the rod in stock, so I'm just going to use that instead of ruining the bolt. We also need Creality style springs, and you can get these on AliExpress 10 for $1, so we need 2. That's 20 cents. We also need 3 608ZZ bearing, and these are available on AliExpress for 25 to 50 cents each. So that's 75 cents for them. In total, everything here should cost 10 bucks.
So the other thing that we need to do is that this build obviously is all designed in metric, and I have a mix of parts here, 5/16 rod instead of M8 rod, and I'm using these number 6 bolts instead of the M3 and the M4 bolts that are called for in the build. So you use what's available, and what we're going to do here is we're going to take some measurements, because like I said in the last video, one of the issues that I had when I just used the STL that's posted on Thingiverse, nothing matched up. Even when I was using the metric bolts, the head on my metric bolt was completely different than the head that was on the STL file that was printed. What we're going to do here is we're going to take some measurements, and then we're going to jump into the SCAD configurations and take a look at what measurements they have listed, and we will make changes as necessary. So these are the 3 things that I'm really concerned about measuring here. So I got my caliper, turn it on, zero it out, and we're going to take a measurement here, and I'm getting 12.65, and we'll take a measurement from the inside also, and here I'm getting 12.88. all right, so we have that measurement. Now we'll check the Nylock. 12.7. And then the number 6 nut. We have 7.73. And 7.87 back farther in the jaw. Alright, so we have our measurements. Now we can go and take a look at the SCAD files and the measurements that are up there. So let's jump to the computer.
Here we are. We have the Greg's Wade page opened up on Thingiverse. So first thing we're going to do is, download the files here. Click on the thing files, and we're just going to agree and download everything. No, we don't want to do Dropbox. So the next thing that we need to do is we actually want to modify this configuration to fit the hardware that we're using. And this is the #1 issue why people have problems using this design. They print the built-in STL files and the hardware doesn't fit, and that's what causes a good portion of the issue. So to do that, we need to make sure that we install OpenSCAD. So you do a quick search on Google, OpenSCAD, all one word, and we get the first hit here to their website. And on the downloads page, we're running Windows here, so 64-bit. And we'll download that. All right, so then we'll take a look at the downloads. And here we are. We have the Greg's Wade STL files and OpenSCAD files. Just open them up. We want to extract them all to a subfolder, which I've already done. So here we are, Greg's Wade Extruder. Here's all the files that we get from Thingiverse. And then we need to step through the OpenSCAD installer. I've already installed this, but we can kind of step through it again. You're just going to say install here. It's going to say it's done, and you're good to go. So now, to step into things, all we have to do is open up one of the SCAD files. So if we sort it by type here, we can see here's all the SCAD files. And one of the first things we're going to concentrate on is the configuration file. So let's open that up. All right, so in the configuration file, basically this file is where they expect us to make any changes to any of the parameters, the bolts and nut sizes. They don't want you altering the metric file, which has the standard metric settings and measurements for those pieces. So if you're using something that's out of the norm, they want you to make the modifications here in the configuration file. And let's take a look at that now. So for my needs, we need to modify the M3 and the M4 settings parameters. So these settings are normally 0. I have already made my changes to them, and we can uncomment them now. And basically this is for the M4 diameter is the spring-loaded screw that we're going to use for tension on the idler. The M3 diameter and the M3 nut diameter is going to be what's used for the pivot pin for the idler itself. Okay, one thing to note here, guys, if you recall, my original measurement of the number 6 nut was around 7.8 millimeter, and you can see I have a diameter of 9.2 here. The way they calculate the hex nut is different, so it threw the measurements off and I had to make adjustments. I'm using the number 6 nut in screw. We make the adjustments here to accommodate the larger size, and really this M3 diameter, this affects the hinge pin for the idler, and there's also a press-in nut fitting on the idler, so that's what this affects. And then the M4 diameter I'm using for the nut capture that's used for the spring-loaded portion of the idler. Once these settings are made, we can just do a render up here to save everything and close that out. Okay, so now that we've got our measurements of our hardware, we can compile some gears. So we will start with the gears themselves, and we're going to do a search. So Control F to find gear 2. nut underscore nut. All right, so this is the shaft right here, and we can see that the dimensions are 14 millimeters as a diameter, and then they're adding 0.35 for tolerances for printing. So when we took the measurements of the head of the bolt, depending where I measured, I got roughly 12.65 to 12.85. So if we cut the difference and we make this 12.75, we should be good. And then if we scroll down here, we can see that there's, and here's a rendering of the gear. We can see that there's different decorations here, so if you want to play with this, you can. I have a couple that are printed with this apparently flower design. It kind of looks like a teardrop to me. Well, I think I liked the spiral #1, so why don't we give that one a shot for something different? Yeah, that looks good. Okay. So once we decide on this, then we need to do a render so we can create the STL. So click render, and that will take a little bit to calculate everything. All right, and it's done. So once it's rendered, then we can click save to STL here, and then we just want to name the gear. We're just gonna call this Fatman Makes. Save. All right, so we adjusted the diameter of the nut to match our hardware, and we looked at the potential decorations and picked one that we wanted, and then rendered the final product and saved it as an STL. So we should be done with the gears. We can close this out, and you can save this here if you want. All right, so we want to run this Ultimate Greg Wade's Bowden bracket version 1.scad file. So this is the primary file here. And we can see the rendering. And so the first thing we want to look at is this around line 32. So these settings seem to work for the ENDER style push fit connector. I have the Bowden push fit D, which should be the diameter as 5.8, and then the push fit thread length as 5 millimeters, and this should allow you to manually cut the threads while you turn in the connector. And then the next thing we want to take a look at is what we're compiling, and that is around line 67. Here we are. So render various parts, and this is where you can pick which one of these parts are rendered. So we can see the bearing washer, and if we just comment this out with 2 forward slashes and click preview, we can see the washer has gone away, and then now the idler, we can comment that out, and now we only have the body itself. So what I would suggest is rendering each piece by itself, and not rendering them together, because then sometimes you'll run into issues like with the original STL file. The idler wasn't actually on the build plate when the extruder body was, and that caused some issues. So it's just easier to have everything its own STL, and then if you want to combine them on the build plate, you can easily do that in the slicer. So we have the extruder body selected here. We are going to render. All right, and now we can save this to STL, and we can just call this bracket. And again, I'll put my initials at the end so I know. And we can go here and comment out the body, and then we can delete the comments for the idler. Again, we'll re-render, and we can save this as idler.